Hi IB, we are on your very, very last application to trig derivatives day for this unit. So we are talking all about taking the derivative of trig functions, but we are going to apply them to a different situation. So word problems and real life situations. If you guys have ever watched Friends, this problem reminds me of the episode where Ross is trying to get a couch up a staircase into his new apartment. And Ross and Rachel have this couch and they are trying to turn a corner. So if you think of two corridors meeting at a right angle, and they are respectively 2 meters by 3 meters wide. All right, let's go ahead and set up a picture here. Okay. So I have two hallways. They're meeting at a right angle, and one is 2 meters wide, one is 3 meters wide. Again, your picture does not have to be drawn to scale, but that's the picture that I've come up with. All right. Theta is the angle marked on the given figure, and AB is a thin metal tube which must be kept horizontal as it moves around the corner from the one corridor to the next without bending. So I have a long metal tube. Okay. All right. So I have a long metal tube, which I just drew, and I'm trying to pivot it around the corner. So in the Friends episode, when Ross kept saying, pivot, pivot, pivot around the corner, that is basically what we're trying to do here, is pivot around the corner and see how long that metal tube can possibly be, AKA in the Friends episode, how long the couch could be, so that I can actually make it around the corner. But I want to have the largest couch that I possibly can. In this case, I want to have the longest metal tube that I possibly can and still make it around that corner, okay? So what we are going to do here is set up, looking at where theta is, I'm already starting to notice that AB is the whole length of my metal rod. And I'm going to say that X is my length from where A starts to the middle, and then I'll call Y the second length. Okay? So if I set up my picture like this, then I can also say, if I draw a horizontal line, okay, along my one corridor, it's parallel to this other hallway that's right here. If these two lines are parallel, then I can also say that these two angles are both theta. If that's the case, then I can start to set up using sine and cosine to represent the length from A to the middle, which is my X length, and my length from the middle to B, which is my Y length, because if I add the X plus the Y, I get the entire length from A to B. So part A is asking me to show that the length AB is given by 3 over cosine plus 2 over sine. Now this looks kind of confusing right now, but let's go ahead and start to make representations of X and Y. I'm going to say that sine, let's see, I've got my adjacent here. Okay, so I'm going to use cosine in this case. I'm going to say cosine is adjacent over hypotenuse. So I'm going to say that cosine of theta is 2 divided by x, because my adjacent is 2, this side right here, and my hypotenuse is x right here. If I look at my other hallway, for theta here, I'm going to say sine is opposite, which is 3, divided by hypotenuse, which is y. Okay? So let's say I want to actually solve for x and y. If I multiply both sides by x and then divide by cosine and do the same for y and divide by sine, we will have isolated our x and our y. All right. So right now I have an expression for x, which is 2 over cosine, and I have an expression for y, which is 3 over sine. If I add x plus y together, I should get the length from a to b. If you take a look at what the question that IB gave us, they said that 3 divided by cosine and 2 divided by sine is equal to a to b, the length. Well, the reason why mine is different is because I set up my hallways so that 2 was my first hallway, where the adjacent side was 2 meters, and I set up 3 to be my second hallway, and that's the opposite side. So similarly, if I had put 3 down here on this bottom corner in the corridor, and I had put 2 up here for the other hallway, then it would come out to be the same. So however you guys set up your picture, it doesn't matter, because both ways you're going to wind up with the same answer. So similarly, there we go. X could also be 3 over cosine, and y could also be 2 over sine, just depending on how you guys set up your picture. So depending on how you set up your picture, you're going to have 3 over sine or 3 over cosine, and then 2 over cosine or 2 over sine. And I'm going to go ahead and add them together to make the length of my long tube. So for part A, it is really just matching what my picture is telling me to what they're asking me to prove as the length. So how do we set up the information for the length? Now I want to actually figure out what the longest tube that I could possibly fit around the corner could be. So anytime I'm trying to maximize or minimize something, so in this case maximizing the length, I would like to go ahead and take the derivative. So I'm going to take the derivative of 3 over cosine and 2 over sine. And I want to show that my answer is equal to this. Again, if I just look at this at first, this looks overwhelming, but I'm going to break this down into pieces. I'm going to take my length, which is 3 over cosine plus 2 over sine. And I want to take the derivative. So before I take the derivative, I would like to rewrite this so that I do not have to use the quotient rule. So I'm going to rewrite 3 as cosine theta to the negative first power, and I'm going to bring sine up as well. Okay? Now I can go ahead and take the derivative of each of those terms respectively, and I will use the chain rule. So the negative 1 will multiply by the 3. I'm going to keep my inside function, drop down one exponent, so I'm going to negative 2, multiply by the derivative of the inside, so derivative of cosine is negative sine. Similarly, I'll do the same thing for 2 sine to the negative first power. Okay? Again, to prove any kind of max or min, I want to take the derivative and set it equal to 0. So if you take a look at the directions, they say to take the derivative, set it equal to 0, and then prove that this is what theta comes out to be. So I'm going to do exactly that. I'm going to set this equal to 0. I would like to clean this up a little bit, so I'm going to go ahead and move my negative exponents to the denominator. So I'm going to have negative 3 times negative sine, that'll be positive 3 sine, divided by cosine squared. And minus cosine theta divided by sine squared equals 0. Since it's equal to 0, I'm going to add my cosine divided by sine squared to the other side. So now I'm going to have 3 sine theta divided by cosine. And then I'm going to have that equal to cosine divided by sine. If I cross multiply at this point, I will have 3 sine cubed. Whoop, where'd my 2 go? Ah, sorry guys, my 2 I forgot. Gotta make sure I bring this 2 with me. So that 2 is right here in the numerator, which means when I add it over, I have a 2 right there as well. Okay, don't forget our 2. So now I have 3 sine cubed is equal to 2 cosine cubed. So now if we divide by cosine, because I'm seeing sine and cosine, anytime I've got sine and cosine, I know I can make tangent. And if you guys look back at what the answer is supposed to be, it's supposed to have a tangent in it, so that can give me a little hint if I'm not sure. So I know tangent is sine divided by cosine. So I'm going to divide by cosine, which means I'm going to try to move this cosine cubed over to the left-hand side of the equation, and I'll move the 3 over to the right-hand side of the equation. So now I'm really, really close. In order to get the tangent by itself, or the theta by itself, I'm going to take the cube root, and then I'm going to take inverse tangent in order to get theta isolated. So let's go ahead and do that. Okay, so I did wind up with the same answer that it asked me to check for, which is exactly what I would like to do. Now, here's my theta. Of course, at this point, I might want to know what this value is equivalent to. So at this point, you could pick up your calculator and go ahead and find an equivalent value. So go ahead and pause for a minute, find your equivalent value for theta. All right. Because we're talking about a real-life situation, I use degrees because it gives me a better reference of how many degrees we're talking about. If we look back at the picture, this theta comes out to be about 41.14 degrees. So look back at your picture for a moment. What this is saying is that when this angle is 41.14 degrees, this long tube is the longest it can possibly be in order to rotate around the corner. So let's see, if we have an angle of 41.14 degrees, that is really the smallest angle possible before we start to turn the corner, which is going to then make our angle, well, bigger in one sense and smaller in another sense, since we're going to start to turn the corner, okay? So at that point is the optimal length of the tube that can actually fit. So let's go ahead and fill out our sine diagram. We're going to take a sine diagram where we're checking theta. So at 41.14 degrees, we're going to check a value that's below 41.14 and above 41.14. So go ahead and pause here and set up your sine diagram. Completing your sine diagram gives you, I used 40 and 45 as my test values. Remember, you substitute that back into the derivative. And this is the derivative of the length. So it's giving you the derivative of the length, but with respect to the angle. So if I have a negative and a positive, that's telling me a minimum. And when it's telling me a minimum, basically that is the smallest our angle is, and which really is making the longest tube possible to fit around the corner. We'll do more of these when I see you guys next.